Hello everyone. Today we shall learn the second part of the chapter 3 latitude, longitude and time of your NCERT textbook practical work in geography part 1. So we shall start with an activity. Here we have activity 3. So in the previous lesson we conducted two activities about the calculation of local time. So this is the third one. So here is the activity. Your 8-hour flight to Rome leaves New York at 8:30 p.m. What time will it be in Rome when you arrive? So the duration of flight is 8 hours and you are going to leave New York at 8:30 p.m. What time will it be in Rome when you arrive? So here we have the solution. To help answer these and other practical problems involving timekeeping, time zones are numbered away from the time zone of Greenwich meridian negatively in an eastward direction and positively in westward direction. So let us see a map. Okay, map number 2. So here we have the Greenwich meridian. So this is the Greenwich meridian. Okay, and as mentioned here, these time zones are numbered negatively in eastward direction. Okay, negatively. Let's see here, we have -7, -9, -10, -11, and positively westward, +3, +4, +9, like this. And you also seeing here negatively eastward, positively westward. Okay, here we're east, west. And the numbers tell how many hours to change your clock to get the Greenwich time. So all these number tell you how many hours you have to add or you have to subtract to get the Greenwich time. Okay, to get the time at Greenwich. So for New York, so New York is in zone 5. Okay, New York is in zone 5. It is here. So New York is in zone 5. That is +5. And so you must add 5 hours to New York time to get the time in Greenwich. So to get the time in Greenwich, we have to add 5 hours to the New York time. Okay, so as for the equation, here the New York time is 8:30, and if you add 5 hours, okay, 0, 3, then it's 13. Okay, 13. And again, if you that is 30 hours. So if you uh, subtract it, okay, then by 12, then it is 3, 1. That means 130. Okay, so here New York is in the time zone 5, so you must add 5 hours to New York time to get the time in Greenwich. Okay, so the time in Greenwich is 1:30 a.m. and Rome is in zone 1, so In Rome, you subtract an hour to get the Greenwich time. Okay, so Rome is here. Okay, -1. So Rome is in zone 1. So in Rome, you subtract an hour to get Greenwich time. Thus, when it is 8:30 p.m. in New York, it must be 1:30 a.m. Greenwich. Okay, as calculated here. When it is 8:30, okay, p.m. in New York, so it is 1:30 a.m. in Greenwich. That is after adding 5 hours. Okay, and if it is 1:30 a.m. in Greenwich, it must be 2:30 a.m. in Rome, since Romans have to subtract an hour to get Greenwich time. So here is like this: 1:30 minus 1, okay, is equal to 2:30. That is minus is plus. Okay, that is 2:30. That means if it is 1:30 a.m. in Greenwich, it must be 2:30 a.m. in Rome. Okay, so with the knowledge that you are departing New York at 2:30 a.m. in Rome time, you can see that after an 8-hour flight, you will arrive in Rome at 10:30 a.m. next morning. So you are going to leave, okay, New York at 2:30 a.m. in Rome time, in Roman time. Okay, you are going to leave New York at 2:30 a.m. in Rome time. Okay, and you will see that after an 8-hour flight, you will arrive in Rome at 10:30 a.m. next morning. That means 2:30. Okay, 2:30 just at 8 hours. 8 hours, that is the duration of journey, hours. That is 0, 3, then 10. That is 10:30 a.m. Okay, 10:30 a.m. You will arrive Rome at 10:30 a.m. next morning. So it is easy to come up with a simple formula for global timekeeping. So we have the formula here: D is equal to Z home minus Z away. Here D is the difference, positive for ahead, negative for behind, that you add to change the time. Okay, then Z home is a time zone whose time you already know. That is the time zone of your flash. And Z away is the time zone whose time you want to know. Okay, and so for New York and Rome, applying the formula, D is equal to +5 minus, okay, and -1. Just +5 is here, then -1. Okay, meaning you must add 6 hours to New York time to get the time in Rome. Okay, so we have got this, that is here 8:30. Okay, 8:30 plus 6, 8:30 plus 6, that is 0, 3, 14. And if you subtract it by 12 to get the 2 hours format. So this is 24-hour format. And if you want to get 2 hours format, then we have to subtract it by 12. Okay, then you'll get this 230. Okay, so to get time in Rome, so we have to add 6 hours to the New York time. So the time in Rome would be 2:30. Okay, so the time in Rome would be 2:30, and as we have already known that, so you are going to leave New York, okay, 2:30 in Rome time. You are going to leave New York at 2:30 Rome time. So we have to add 8 hours, okay, to the Rome time. So duration of journey is 8 hours. Okay, so this is the time in Rome, and this is the duration of journey. Okay, so here 0, 3, then 10. So this is the time. Okay, so when you arrive Rome, the time would be 10:30 a.m. Okay, and so this is the answer. And so about the map, I have already told you. So the world is divided in 24 time zones. Each of which is about 15 degrees of longitude. Okay, each time zone is of about 15 degrees of longitude, and each of which represents 1 hour. Okay, just we have already learned that 15 degrees longitude represents 1 hour time, and the numbers on the map indicate how many hours one must add or subtract from the local time to get the time in Greenwich meridian. All these numbers, okay, all these numbers tell, okay, how many hours one must add or subtract from the local time to get the time at Greenwich meridian. And when you are, okay, when you have this free time, when you get the time, so you may analyze this note. Okay, next we have general rules for selecting standard meridians. Let us read. In order to maintain uniformity of time as far as possible within the territorial limits of a country, the time at the central meridian of a country is taken as a standard meridian, and its local time is taken as the standard time for the whole country. Okay, just let us say this is a country, and so this is the meridian passing through the middle of the country. So in general, the meridian which is passing through the middle of a country is taken as a standard meridian for the whole country, and uh, the time along this line would be considered as a standard time for the whole country. So the standard meridian is selected in a manner that it is divisible by 150 degree or 7 degree 30 minutes, so that the difference between its standard time and a Greenwich Mean Time may be expressed as multiples of an hour or half an hour. So this is the second rule. For example, the Indian Standard Time is calculated from 82 degree 30 minute east meridian passing through Mirzapur in UP. Therefore, Indian Standard Time is plus 5:30 hours from the Greenwich Mean Time. Okay, so we are ahead, okay, of the Greenwich Mean Time. So plus 5:30 hours from the GMT. That is 82 degree 30 minutes multiplied by 4 divided by 60 minutes. That is 5 hours 30 minutes. Okay, so we have already known that 1 degree is equal to 4 minutes, and that is why we are multiplying it by 4. So it is like this. See, 82 degree 30 minutes can be taken as 82.5. Okay, that means since we have 30 minutes in a degree, okay, so we in a degree we have 60 minutes. It means that means 30 means 0.5. Okay, 1 by this 1 by 2 half. So we may take this 82 degree 30 minutes as 82.5, and if you multiply it by 4, okay, so it becomes 330, and if you divide it by 60 to get hours, okay, then it becomes 5.5 hours. That is 5 hour 30 minutes. Or alternately, we can also calculate like this. So we may convert these okay degrees into minutes. Okay, to make the same unit. So just we have to multiply 82 by 60, then plus 30 divided by 60 to get hours and minutes. That is 82 multiplied by 60 is 4920 plus 30 divided by 60. That is 82.5. That is 82 degree 30 minutes. So it is like this. If you, for example, 4920 plus 30 is equal to 4950. Okay, so if you divide 4950 by 60, okay, then 8 for IT, okay, here 5 1 0, then at 2 0, okay, 120, that means 0 3. So 82 becomes okay, this is the degree, 82 degree, the remainder becomes the minute. Okay, so 30 is the remainder, so it becomes the minute. And about this Indian Standard Time, you may try, okay, you may try this at home. About the selection of the standard meridian of India, you may try this one. So our standard time is meridian is 82 degree. Okay, you have to multiply it by 60, then plus 30, then 7 degree multiplied by 60 plus 30. So what is the result? You will not get any remainder. Okay, So next we have the last topic, that is international deadline. So the international deadline established in 1894 passed through the mid-Pacific Ocean and roughly follows 180 degrees longitude north and the south line on the earth. Okay, 180 is here. This is here we have 180. It is located halfway around the world from the prime meridian. Okay, prime meridian is here and the 0 degree. Okay, it is the 0 degrees longitude established in Greenwich in England in 1852. That means Greenwich meridian was established in 1852. Okay, its value is 0 degrees longitude. So Greenwich is here and 180 degrees here. The international deadline is the international deadline functions as a line of demarcation separating two consecutive calendar dates. Okay, so this is the point of reference. This is the line of reference for determining calendar dates. Okay, that one, that two, that three, like that. And when you cross the deadline, you become a time traveler of sort. Cross to the west, it's 1 day later. Cross back, you have gone back in time. Let's see here. Here, this is Greenwich is here. Greenwich is here, and international deadline is here. Okay, so here this is 15 degree east, 30 degree east, 45 east, 60 east, 75 east. Okay, then 90, 105 east up to this 161 east. And here we have this 15 degree west, 30 west, 45 west, 60 west, 75 west, 90 west, 105 west, 120 west, 135 west, 150 west, 160 west. Okay, here this is and is. Let us see. Okay, so let us read the statement again. Here, when you cross the deadline, you will become a time traveler of sort, and across to the west, it's 1 day later. Cross back, you have gone back in time. Say, for example, you are here. Okay, so you are here. So when you cross to the west, here, okay, west is here. This side is west. Here we have east, and this is west. Okay, so when you cross to the west, okay, let us say you are here and the day is Monday. Okay, just here, the day is Monday. The day is Monday. And when you cross to the west, then it becomes Sunday. It becomes Sunday. Okay, just here, it becomes Sunday. That means 1 day is lost. Okay, so 1 day is lost. And similarly, okay, see, you are here and you are here, and so when you cross the international deadline, okay, towards the east here, let us say uh, the day is Sunday. Okay, here the day is Sunday. The day is Sunday, and when you cross the international deadline towards the east, then it becomes Monday. Okay, it becomes Monday. Then means 1 day is gain. Okay, 1 day is gain. So you are enjoying Sunday here. Okay, you are enjoying Sunday here. Let us say after half an hour, you are crossing the international deadline towards the east, and suddenly it becomes Monday. Okay, that means you are gaining 1 day. And in the first case, so on Monday you are here and you are enjoying Monday here at this place, and when you cross the international deadline towards the west, okay, it becomes Sunday. That means 1 day is lost. Okay, you are going back to the time. So another example is here. Okay, a person moving eastward on Tuesday will count the day as Wednesday once the international deadline is crossed. Similarly, another person starting his journey on the same day but moving westward will count the day as Monday after crossing the line. So this is the international deadline, and here, okay, we have already known that this is west, and here we have east. A person A is here, okay, a person A is here, and he is enjoying Tuesday. He is enjoying Tuesday, okay, and here, as per the statement, he is crossing the international deadline towards the uh, east. Okay, and so when he crosses the international deadline towards the east, okay, moving eastward, see here towards the east, the day become Wednesday. So here the day become Wednesday. So in the other case, another person B is here. Another person B is here, and he's enjoying Tuesday, and he is crossing the international deadline westward. Okay, and the day becomes Monday. The day becomes Monday. Okay, if he crosses the international deadline westward. Let's see here. Okay, and there's another person starting his journey on the same day. Moving westward will count the day as Monday after crossing the line. And the last point, despite its name, the international deadline has no legal international status, and the countries are free to choose the date that they observe. Okay, it depends on the government, okay, of that country, which that he has to observe. Okay, and so since it has no legal international status, okay, the countries are free to choose the date that they observe, and while the deadline generally runs from north to south, okay, the deadlines here is running north to south, okay, north to south, from pole to pole. It zigzags around the political borders, such as eastern Russia here. Okay, here eastern Russian part, it is zigzag. Okay, and the Alaska Aleutian Island is here. Okay, Alaska Aleutian Island. So in this way, international deadline is not a straight line. Okay, it is zigzag at many places. Okay, depending on the administrative units. See here, it is also diverted, deviated. Okay, and here also. So this is about the international deadlines. That's all for today. Thank you very much.